Good morning, everyone. We are going to do some problems on Stack this time. And I hope you guys got a chance to look at the problems we will be discussing. So my idea is to begin with a simple, introduction of Stack a little bit. And then I have a question for you. If you guys went through the questions, can you tell me what in particular we are going to talk about? Anyone?
Like increasing or decreasing arrays?
Yeah, that's right. So yeah, like a stack is huge, like we can use it in so many ways, but this particular session is focused on, we can call it monotonic stack, and we will go through the concepts and we'll go through some problems and we'll see how to apply those concepts in those problems. So with that, let me start sharing my screen. Okay, so you guys can see my screen, right? Let me make it bigger. Yeah. Okay. So can someone tell me in general, when do you need to use a stack? And what is a stack? Like, it's not a very super basic session we are going to have, but which kind of like data structure stack is? It's good to start with that. So yeah,
First out.
last in, first out. Yes. So stack is last in, first out. That's right. I'm assuming like, you guys know about this already. So when do we need a stack is, what does that mean? Last in, first out. So, okay, some of the things I put in my stack here, 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 and then whoever came last actually came first, it will stay here for more time than the guys who are coming on top, right? When can we need that? Like if you see when programs are running and you do, for example, recursion. So if this guy depends on anything I'm doing here, it depends on something here, then this guy has to wait here, right? So similarly, programs also create their own like function stack, same concept. It has to wait till these guys finish. This has to wait because he may be dependent on some of the outputs from the previous guys, and then it can work on its stuff. Similarly, whenever you are working on something, like something important comes up, you stop it, you keep some information so that you can come back and work on it. So that's the basic use of a stack. So we'll start with one example, very simple example. For example, you have been given number, say like 1, 5. I will change the number depending on what I want to demonstrate. I haven't thought about an example yet, but say 1, 5. And what I'm interested in is to figure out the first left guy who is smaller than me. So for in this case, 1 is the leftmost guy, so he can't say anyone is smaller than him. So we can choose any number. Normally we choose -1, so I am fine with that. Like let's call it -1. For 5, how will he know that what is smaller than him is, there are 2 ways. The brute force way, like, okay, when we are at 5, we can continue going leftwards, right? So what I'm saying, like you are given an array, many values. If I want to see, okay, what is the leftmost guy which is smaller than me, then what is the brute force way you can do? You can just start a loop from here. You go back in this direction and find who is the first guy who is smaller than me, and that's the output, right? Is that clear?
Yes.
Great. In this particular case, like 5 can look at the element towards its left because there are only two numbers and say, hey, actually one is smaller than me. So that's fine. What about if 2 comes? If 2 comes, now 2 cannot just look at its leftmost guy and make that decision. So for this guy, he has to make as we talked about, brute force way, he will go check 5 and then he will go check 1 and then he can make a decision. But the important thing is, having 5, will it help us ever? If 5 was not here, for example, and we were suppose having this value on a stack, suppose 1 came here, then 5 came here. As soon as 2 came here, I looked at the stack top and I say, hey, actually 5 is not smaller than me. So let's pop it out, and then I will check the peak of this. Luckily it's 1, so I will say 1 and we'll insert 2. We'll see why we are doing that. Because now suppose 6 came. So when 6 came, he doesn't need to go through anyone else. He can just look at number 5, whatever is on the stack top, and he can make a decision. So in that particular case, we will add 6 and we can continue moving the same way. As soon as someone greater comes, no problem. But if something smaller comes, then we will find a better place for, like, for example, now we have 3, then 6 has to be kicked out and 3 will come here, and 3 will look at it's before inserting what was just before him. So we can say, hey, the next guy was 3, sorry, 2. If you process this way, then what is the time complexity for this algorithm?
O of n.
O of n, yep. And space complexity also O of n. In this particular case, in the brute force way, what we were doing, we were starting from every place and going all the way to left, and then it will be what? O of n square and no space, right? Okay, so that is, if that is clear, then I will tell you something. Is that clear so far?
Why space is O of 1?
In this particular case, it's already given, so I'm not counting a space for the input, but you are iterating from starting with any I going towards left, checking one by one who has value less than me. So do you need to store that value or not in this particular brute force approach? You don't have to, right?
So yeah, it's O of 1 because we are iterating over the same array. We are not using any additional memory.
Okay, thanks. I was thinking O of n because array is already there, that n number of elements.
Yeah, so when we talk about space in general, we talk about the extra space you used, for that. So if the input already has something, you can ignore that. That's what I clarified also. But yeah, now based on that assumption, now it's O of 1. Is that fine?
Yeah, thank you.
Okay, yeah, no problem. So far so good. We are on track so far. So now look at this, like the stack we were building. So what we are doing every time, what is the eventual current state? It is 1, 2, and then 3. So at each point of time, what we are doing, we are maintaining increasing stack, right? So we also talked about it earlier, like in previous session about intervals. When things are ordered, you can make some observations which helps to solve like a lot of problems. So in this particular case, just by keeping things like, increasing from left to right is giving me some information which I'm able to use to, like, better to use it, get a better time complexity. Because I know that if something is uh, bigger than 3, for example, that I need to check it with 2 or 1 or anyone. So we always have this kind of like, data where we just maintain those values which are useful for me. Anything unuseful, we just remove it. That was the concept I was trying to talk about here. When in the function stack, you keep things which are useful for you. If something is not going to be useful, we can just remove it and continue with the, like, next, guys. So that's the, like, big picture. Now we will talk a little bit in detail about this concept. So our whole session is going to be about this thing. So the session should be actually called Monotonic Stack. We are going to talk. So the brief overview is we'll go through one basic thing which I want to talk about next, and then we have like 8 problems. I don't know how many we can do it, but I have submitted solutions for each of the problems, and also the basic which I discussed, it's already shared. So after the session, you can go through it, you can debug through it. What I don't want to talk about too much in detail is like optimizations, because okay, we are using a stack here, but can we do things without using any stack? Maybe we can, but then the focus will change. So the entire focus is, after this session, you should start to think about monotonic stack, how to use it. And since these are all lead code questions, I'm pretty sure this will come often in other sessions. Then we can talk about all the different approaches to solve, like, the same problem, where monotonic stack could be just one of the possible solutions. Maybe there are better solutions. So is that fair? I just want to make sure that we optimize the use of our time here today. All right. So with that, I will give you an example, like, array 8, 6, 4, 5, 7. And what I'm interested is a couple of things. First, I'm interested in, give me first smaller to left. Second thing, I want first smaller to right. Third, I am interested in first larger to left. And the last is first larger to right. So we have to fill this value together. Once we will fill this value, we'll know that we know the problem, and then we will see how to derive this. And we can have the same thing, like if there is no value which is like matching this criteria, we'll put -1. So for 8, we'll start with this guy. Work with me, like someone should be like, if you have figured it out, tell me, what is the first smaller 2 left for 8? If it doesn't match, we will put -1 there, by the way.
-1.
Great. So -1. For 6, what is the first smaller 2 left?
-1.
Great. For 4?
Same, -1.
Perfect. For 5?
4.
Excellent. For 7?
5.
Okay, so that's clear. So now we will do the same thing for first smaller to right. So let's fill this value. First smaller towards your right. So for 8, who is the first smaller towards its right? 6. For 6, it will be
4.
4. For 4, it will be what?
-1.
For 5?
Same, -1, -1.
-1. Great. Now first larger to left. So for 8, first larger towards its left. There is nothing towards its left, so -1. For 6, first larger, so 8. For 4, first larger is 6 towards left. For 5, first larger towards its left is still 6. For 7, first larger towards its left is 8. And here, first larger towards right. So for 8, 8 is the biggest number, so I know that -1. For 6, I think it could be 7 here towards right. For 4, the first larger is 5. For 5, it should be 7. And for 7, there is nothing towards its right, so it's -1. Okay, so now we have this value. If you guys remember, we kind of solved similar problem where we were probably doing one of this, finding probably one of this. So if we can understand this concept, we are basically going to solve 4 problems in one go. And also we are going to derive understanding which will help us solve more problems. So now with that, like, let me erase this and work with you to derive some, like, some important things here. If anybody has any problem to understand this, ask now. We can wait for some time. We can go through it. We are good? Okay. If we are good, then like, okay, that's fine then. Let's go through it. One observation. When you have points in increasing order, may not be linear, so don't think it's in a line or something, but something like this. So this is the case of increasing stack as we were looking at it earlier. Suppose the rule is that whichever guy comes next should get added to this particular configuration. Maybe think is like this is the height of the people, and my height is actually I'm falling somewhere here. For example, I'm the new guy which needs to be inserted, and I'm falling here. So to maintain this order, what we have to do, we have to remove these 2 guys because I have to be the last guy. So these guys will get removed.
Your cursor is not on the screen. Okay, I got it.
Can you guys see it? Others?
Yeah, now I am able to see.
Okay. So I will repeat the thing again to make it clear. So we had increasing height, like people are arranged in that way so far, and it's my turn. And the thing is that I will always be the last guy. And also we need to maintain the increasing order. So I was this guy, for example. So you have to remove these 2 guys, right? Because if these 2 guys are there and I am the last guy, we cannot maintain the increasing order. Clear?
Yes.
Great. So now when I got inserted here, what information I can note here that, okay, towards my left, this guy is towards my left. So I can immediately put in my notes that, hey, the leftmost guy, like, or first smaller to left, is whatever is on the stack so far. This was our stack basically. We are putting this value, and then I came here. So I kicked out these two guys and I am on top now. So for me, I can just note whatever is currently on top before I get pushed on it. That is the guy who is the first smaller to left. Is that clear?
Yes.
That's good. Or maybe let me give example. So 1, 2, example means better, the easier to understand. 5, 7. My height is suppose 4. So in the beginning, you had this thing 1, 2, 5, 7 on the stack. It's my turn. My height is, for example, 4. So we kicked these two guys out, and now the configuration is like this. So for me, I can say the first guy towards my left is whatever is on the peak. Because when I kicked these two guys out and I didn't insert myself, this guy was on the top. So I can easily say whoever is on the top is the leftmost guy, at least for me, like who is smaller than me. So that is one information. And we already talked about it previously. Now the thing is, can these guys who got kicked out, 5 and 7, can they make any useful information? Can they note anything useful?
Maybe like when they are kicked out, they know the top of the stack, and they know like what's the number which is smaller than me.
Yeah, they knew that when they were actually inserted itself, right? They knew that.
Yep.
That's right. But during this particular event, when I am being inserted, can they note anything useful information here? Can they say anything about like who is the first smaller guy to him towards right?
Yes,
For
makes sense.
Yes, it is.
it,
The current one is the smallest one to the right.
exactly. So that's a very useful information, because now when they got kicked out, still they can also make some useful information that the guy who is coming now, like in this case me, they can put, hey, actually the first guy who is smaller than me is the guy because of whom I got kicked out. Think it as like a rank in an exam. So first, second, fifth, seven, and then I came with a fourth rank, for example. So these guys can say, yeah, the first guy towards my right, first smaller rank towards my right was this guy who had rank 4. Is it
Makes
clear?
sense. Makes sense.
Awesome. So these two observations we made. So we now know with first rule while inserting. So while inserting, when I am popping out other guys, they can also add something to their index, some important information. And once they got removed and I got inserted to my position, I can also put my value that, hey, I know whichever is on the stack now, he is towards my left and he is smaller than me. So in this case, what I am saying, I will say, so first smaller to left for me, for 4, I was 4. So for me, I will say first smaller to left is 2, because when I got filled in here, 2 was towards my left. Finally, he was on the top when I got inserted. For 5, when he got kicked out, he know who, because of whom he got kicked out. So he can make this claim that first smaller to right was 4. Same with 6. 6 will also have this same thing. Like first smaller to right is 4.
I believe 7.
Oh, sorry, 7. Yeah, thanks. 7 had the same thing. Great. So if this is clear, then we go to the next one. Is this very clear? If not clear, feel free to ask, because this is more important than doing questions, by the way, guys. So
Hey,
uh,
Roger,
yeah.
I have a question. So, after 7, if 8s come, like
Mhm.
8, then because we popped out 5 and 7, and 7 is smallest number from 8. So, but 5 and 7 are is not in stack right now.
Yeah, so let's like, for simplicity, we had this arrangement, for example, 1 2 5 7, and then I came, right? I came as 4.
Yes,
Now you are saying 8 came.
yes.
So when 8 came, his like, first smaller to his left is me actually. 5 7 doesn't matter to him anymore.
Okay, got it.
Got
Yeah,
it?
yeah. Thank you.
Yeah, so that's why when we are in maintaining this increasing sequence, we know some of the values. We just talked about it previously, which is of no use. We are going to pop it out. But thing is, when we are popping out, at that time also we can make some useful observation. And I'm trying to demonstrate that with this particular example. Like first smaller to right, these guys can make that observation and fill those value. So for 8, nothing is towards his right, which is smaller, right? But if 2 comes, then what will happen? 2 will pop out 8, right? So 8 can fill, hey, actually I got popped out because of someone came which is smaller than me. So he can do the exact same thing, that I know who is smaller than me towards right. So he will say, okay, I know 2 is the value, which is first smaller value towards right. Clear? Any
Yeah.
questions? If not, then we will go to the same thing, but now we will go to the decreasing sequence. So also one thing, when we maintain the increasing sequence, remember, when we are maintaining increasing sequence, then we are able to derive smaller values towards both direction, left and right. Now we will see, if we do the decreasing sequence, probably we will be able to derive the larger value towards left and right. That's where I'm trying to go next. It's the same exact idea, so I think it will be very clear. It's like symmetric case. Okay, so in my same story, you have this thing, this configuration. So let's make it same actually. 6 5 3 2. This is the current configuration. 4 got added here. What we want to maintain in this particular case is decreasing sequence. So when 4 comes, 2 has to leave, because 4 has to be the last most guy. So he will pop out 2, he will pop out 3, and then 4 gets inserted. When 4 gets inserted, the important information 4 can make, that who is first larger to my left. So who will be the first larger to 4's left is 5, right? Whichever was on the stack top. So this was the configuration 6 5 3 2. When 4 made the entry, 4, what he did, he popped out 2, he popped out 3, and then before he got inserted, he can look at the leftmost guy and say, hey, actually 5 is the guy who is first larger towards my left. So for 4, this value will be 5. Now same thing, when 3 and 2, they were getting kicked out, what they can claim. For 2, first larger to right is who? Because of whom he got kicked out,
4.
right? Does that make sense, guys?
Yes.
Great. So with this, I think you know the process that, okay, if I have to find something larger, first larger towards left or first larger towards right, then I should build a monotonically decreasing stack. But if I have to get the smaller towards left or smaller towards right, then it's better to build a increasing, monotonically increasing stack. Clear, right? If it is clear, then actually I will show you the code a little bit. I got time to write that code and I didn't find in this particular problem, but I think this will be a very good problem if it is posted for at least, this is the basics of all the possible combinations of these questions, like what you can be interested in, either in left or right direction or smaller or larger. So this particular idea gives you all these 4 things in one go. So
Could we walk through one example?
oh yeah,
Initially, let's say the top
yeah,
two array was empty.
yeah.
And
We can actually walk through this particular example if you want. Do you want
Yeah.
me to? Yeah, sure. Let me try to clear some of it. 8 came. So I am interested in building the increasing stack. Okay. So my idea is build increasing stack. 8 came, I put 8 in the stack. And in the beginning, let me initialize all this value to -1, right? Because we know by default everything is -1 if we don't fill any value. Where the, okay, 8, 4, 5, 6, 7. And this is first smaller to left. So I am solving, okay, actually I'm solving this guy first here. And this guy here below it. 8, 4, 5, 6, 7. Okay.
It's 86457.
8, 6, 4, 5, 7. Okay, thanks. 8, 6, 4. Actually, let me erase if I can. Also, let me erase this. Yeah. Eight, 6, 4, 5, 7. And by default, if I'm not filling, let's think this is -1, because otherwise the drawing will not look good. Now 8 came, so I'm processing from this side, left to right. Also guys, we can, depending on the problems, we may choose to run this from left to right or right to left. Depends how the problems ask me to, and gives me useful information. In this particular case, I'm going from left to right, iterating on this. So 8 came, nothing is there. So I will just put it here, 8 on the stack. And my idea is to build an increasing stack. So I always want to see something like this. Any new value should be the biggest one. 6 came. So 6 came, then what we can do when 6 came, so this is a increasing stack. So 8 will be moved out, right? So 8 got kicked out, and then 6 is on the top. Now when 6, we want to insert 6 on the uh, stack, it doesn't find any element. So 6 knows that there is no value which is smaller than me. So this value will remain -1. This is by default -1. So this will remain -1 for 6 because he couldn't find anyone towards him left. Here 8 got kicked out. So when we know that thing, that when something got kicked out, he can claim that there is something towards my right which was smaller, which is the current guy, right? So during this process, he will say, actually, I know someone who is towards my right and is smaller. So 6, he can fill that value. Now we will have 4. 4 will do the same thing. 6 got kicked out. 4 is on the top. And when 4 will look, nobody is towards his left. So -1 will remain here. And 6 got kicked out because of 4. So he can say, hey, this value is 4, which was smaller towards my right. 5 came. So here is 5. So for 5 didn't have to go through kicking out anyone, because whatever was on the stack peak was already smaller than him. So he can fill, hey, what is on stack peak? 4 is on stack peak. Okay, so he knows that 4 is smaller towards him left and is smaller. So 4, there will not be any kick out process here, right? So it will remain like this. Nobody got kicked out. Now 7 came. 7 will maintain this same thing. So when 7 came, it will look at who was on the top. Nobody got kicked out. So it can say, okay, 5 is towards my left, which is smaller. And 5 will have nothing, so nobody got kicked out. And by default, as you know, if nothing is filled, it is -1. Now, if you look at the value which we derived in the beginning, you got the exact same thing. Is that clear? Is that clear, or questions, or we want to go through the second one? We can do that too.
I believe like silence is no questions.
Okay. I hope it is not very tough, but yeah, if it is the first time, maybe slowly you will get used to it. That's why I would highly recommend after this session, again, watch this, go through the problems. And that's the reason I have put the code also this time, that go debug it if it doesn't make sense, because you know a way to figure these things out: smaller, larger, towards left and right, especially the first ones. And that there is a way. So with that, let me try to show the code a little bit. Maybe that will give a better idea. So where was that? Maybe here I put it. So it's the same example, guys. So you would be able to debug it. That's the reason I created this example. This could as well be a very good problem, by the way. What we are doing, we are going to calculate these 4 values: smaller to left, smaller to right, larger to left, larger to right. We pre-filled everything with -1. And then I am building increasing stack and I am building decreasing stack. So my idea is, when I will build the increasing stack, I would have the value for smaller values, like first smaller to left and first smaller to right will get pre-filled. And then same with decreasing stack. these two guys will get updated. So this is a boilerplate code, like just preparing things. This is the most important piece here, these 5 lines. So let's look at it, what we are doing. So we know the numbers length integer array. I already have that value. I created a stack, and then what I am doing every time, if you remember, we went through this process. Whenever a new guy comes, what we do, we check his position that, hey, do we need to kick out anyone? If we need to kick out anyone, then those guys who are kicked out, they can note this information that the person who just came in and because of whom I got kicked out is the first smaller towards my right. So that's this line, exactly same thing we are doing. After we are done, or maybe we didn't need to go through this while loop, then the person, like when I came, I looked who is already on the stack peak, because I know whoever is on the stack peak is the first guy who is smaller than me. So I filled this value and then I added myself to the stack.
I believe like you are adding the indexes here or the actual numbers.
So I am using index in this particular example. And by default also, like, if it is not very complex, try to add index, because when you have index, you can find the number, but not the other way, right?
Yes, like, I believe like the indexes makes more sense
Yeah,
because of the lookup. Like we can easily look up in an array
exactly.
and then figure out the larger or like a smaller one to the left or to the right. Yeah, makes sense.
Yeah. So that's
Hey,
my, yeah, go ahead.
Can we? I don't think we could putting a number not work, right? If we put a number of the value, I don't think it's gonna work because we don't know what index.
That's right. You're right. I said, like, in general, I can see, hear my voice, guys. Why? Okay, it's better now. In general, even if you think like it's okay to put values, by default, if you put just index, you can access the value, right? But not the other way. So it's always safer to put index. That's the thing I was trying to convey. Does that make sense?
On the example 3, right? So the first larger to the left, it has 8, 6. Is that index or is it a value?
It's the value.
Okay.
Yeah. When I'm printing out the value. So yeah, so this was the increasing stack. Similarly, same logic we talked about for the decreasing stack. We go with a number, we create a stack, we go through this loop, and in this particular case, as I talked about, when we are maintaining the decreasing stack, the guy who got kicked out will be able to note this information that who is the first guy towards my right and who is larger. That would be the guy who is being considered. If a stack is not empty, then before we add to the stack, we can fill this value who is larger to left. Whoever is on the stack currently is the first larger value, because we are maintaining the decreasing stack. And after that, we are going to do this. So if you look at these two, they are very, very similar. It's not tough to come up with this after you, like, write couple of times similar, like, problems you solve. It's like mechanical. Is it clear? This is the core concept. I mean, this is the whole class actually. This is the main thing. So any problem, if you don't understand this, then spend more time on this, I would suggest.
Can you
Can
guys
someone mute it?
yourself? Yeah. I will like Roger. You can mute because you are the host.
Okay, let me try. Is it better now? Yeah.
Yes.
Okay. So
I have a question. Like, can you go to the code?
yeah, sure.
Can like share your screen? Yeah. So line number 29, build where we are building the increasing stack. Okay. And from this function, we are able to figure out first smaller to left and first smaller to right.
Right.
Okay. What we use the same code and traverse the numbers in from right to left. Okay. And use the same logic, like build the increasing stack.
Yeah.
And can we figure out the first larger and first largest to left and first larger to right?
Right. So exactly, like when you are traversing from the right side and you are building increasing stack, so you are essentially doing the same. I think you should be able to derive that. I
Yes.
haven't coded, but yeah, please go through that.
Because it looks like symmetrical, like the way you talked about it.
Yeah.
So maybe using this function build increasing stack,
Yeah.
if we just traverse the array from right to left, we
Yep.
should be able to come up with first larger to left and first larger to right.
Yeah. Worth a try. I
Yeah.
think please go ahead and experiment. That's the reason I gave this code, feel free to tweak it.
Thanks.
Yeah, no
Yeah,
problem.
I think the main idea is to maintain the property on the stack, as Roger draw. And then when we insert the node, we always make sure the current node is the one on the top of the stack. And the stack, order is maintained. Then it should work.
Yep, that's the core concept. Anyone has any questions? Because now we can move to the questions I posted. We can go through some of them for sure, where we are using the same concept. So that will help you that where it is actually used. I created this problem. It was not in any I couldn't find this exact in lead code or anything, but I try to make it as generic as possible, which can help you apply this concept in different situations. So if there is no question, I can start with the first question for today. Okay, silence means either it's going great or it's going pretty bad. So guys, please let me know. Should we just move it?
Yes.
Okay, thanks. Let's try this then. So what was the chat? Let me check the chat. No problems. Okay, thanks. Now we are going to this problem daily temperature. Now we'll see how we can apply some of it. So have we done this or not? Please share Ripple it link. I have shared everything. Like if you go to the lead code practice, today morning, 2 hours before, earlier, I have already shared everything, the Ripple link plus all the solutions for today. So take a look. All right, back to the problem, daily temperatures. So you are given daily temperatures. So 73, 74, 75, this 73. Your output should be 114 because we are looking for a warmer temperature. Okay, so the problem is when would be the next warmer day? So from 73, if you look, the first day which is warmer is 74, right? So this value will be 1 day. That 1 day after today is the warmer day. For 74, it will be again 1 because 75 is the next warmer day. Here is interesting, 75. So for 75, you have to wait 71, 69, 72, and 76. So there are 4 days in between before you will get a warmer day. So that's why for 75, this value is 4, and so on. So now what you are looking at is what is the first day towards your right, which is larger than you. So we can say first larger to right, right?
So we will maintain decreasing stack.
Yes. So now that was my question. You already answered that you are looking at first larger towards it, right? So you will go through this decreasing stack. Is that clear? When we look at smaller, then we maintain increasing stack. When we look for larger, then we maintain decreasing stack. So if that concept is clear, then now should I even draw example, or I can just go through the code? We'll see, we are writing the exact same code. So first my question is like, do you guys have any question on this question?
No.
Okay, look at the chat. It's really not easy to find your chats actually. Does anyone have a good idea how to look at chat while going through the session? It's very inconvenient, or I don't know how to use this thing.
Don't worry. Like I was just posting the link to the solution.
Okay, yeah, please someone if can answer that common queries, please. Yeah, do that. Thanks for that. So guys, this problem is, we have already solved this, as you can see. So we created a stack here. We went to all the temperature, and we are trying to maintain decreasing stack for the reason we just talked about. So if we find such days, in this particular case, we are saying how many days I have to wait. So that's why you have to put this value in the index. The duration, it's not the index. It's basically like when 76 comes, then 75 could be filled with this value that, hey, I had to wait for 4 days. So this is where we are going to do that. And then we maintain this decreasing stack as usual. It's the same problem, just story has been changed that, okay, it's a daily temperature thing. And now instead of the value, they are telling you the difference, like how many days. So based on the index, you should be able to figure that out. Just the subtraction of the index for these two values will tell me that thing. Fine. Or any problem? Should I draw this to make it clear? Let me know. I can draw this example and I can show you how we can derive that. It's not a big problem.
I guess like it is straightforward.
It's straightforward, right? Exact same thing we already solved, right? That's what I think too.
What is the time complexity O of n?
Yeah. What do you think? Should be open.
Yeah, I was thinking like we have a while loop inside. So
Yeah, it's a tricky, but think about it. The people who got kicked out, they are not again in the picture, right? Because you start popping things out also. So they are not part of your stack anymore. So that's why, even though there is a while loop, it's often.
okay.
Okay. So next problem. Shortest unsorted continuous subarray. So you are given a subarray. Okay, let me go through this problem, try to explain you. So you are given this subarray, for example. 2, 6, 4, 8, 10, 9, 15. So they are asking you, what is the shortest subarray which you can sort to make it actually sorted? So this is the thing. Okay, the question is clear, because if I sort 6, 4, 8, 10, 9, then this will get sorted. Then everything towards my left is already sorted, towards my right is already sorted. This, if this middle thing gets sorted, then the overall array will be sorted. So that's the problem. You have to find what is the length of this unsorted continuous array. So I can try to explain on the drawing board also, but yeah, let me go through it. The problem will be something like some value. Suppose if it was all sorted automatically, then you will have increasing kind of sequence. Not a straight line, but I just drew it because it's easier to draw a straight line, but everything is increasing. In this particular case, you can have something like this. Hey, like it increased up to some time and then it decreased and then it again went up, right? Things like that can happen. Or it can have more like, such thing like, okay, increase, decrease, increase, decrease, something like this. So in this particular case, if you sort some values in this area, like wherever it is, then probably this will get sorted. Something around this area, if they get sorted, it will be overall sorted. So your example was actually 2, 6, 4, 8, 10, 9, 15. So what information you can make if everything was sorted, then you will never see this thing like, this, nobody will be kicked out in the process, the kicking out process which we just discussed. When you are building something, then and nobody is getting kicked out, then you know that everything is in order. But what will happen in this particular case, when after 2 you will add 6, things are okay, but after 6 when you will add 4, things are not okay. So you have to kick out 6 here, right? So if you have to kick out 6, then that means you have to actually consider looking here, because we know that actually, hey, there is some problem here. So maybe you will say, okay, look at this guy. Now, as Gaurav was saying, like, from this side, if there is something sorted, if we start looking from this side, from the right side, so from this side, so if things were all the things were sorted, then the decreasing stack, if we build decreasing stack from the right side, it will also not see any like, kick out process, no exception to the rule. So in that particular case, things will be okay. But in this particular example, if you look at it, 15 to 9 is fine. But when you come from 9 to 10, you know that it is not it is not decreasingly sorted, because we found a value which is not adhering to this decreasing rule. So now this is the guy which we have to consider. So the idea is, if we can find these two extreme ends and we sort these two, then we know that overall it is sorted.
Hey, like, I have like one question here.
Yeah.
What if the previous numbers are, let's say, 20, 19, and 21,
20, 19,
and
20.
21, and then the same array, 8, 10, 9, 15.
Oh, you are saying the same array. I should append these values, you are saying?
No. Like instead of 2, 6, and 4,
Yeah.
replace these.
Okay. So 20, 19, so 264. Okay. Make it 20,
Yeah, 19
19,
and
21.
21, and then like 8, 10, 9,
8, 10, 9, 15,
15.
right? So when you are,
Because in this case also, yeah.
yeah. So in this case also, when you will go from left to right in the increasing sequence, so 20 will be the first guy who is not adhering, right? Because I'm first going through left to right, building an increasing stack to figure out this left side of the extreme.
Or instead of like 19, like maybe I just like messed it up. We take like 20, 20, 22, and then 21.
20, 22, and
And then
21.
21 then, yeah. So
Yeah,
just trying to take the same example, because here also we will figure out that 22 is the culprit.
yeah, yeah. So here again, 20, 21, 21. When 21 comes back, so we definitely know this guy is not at the right place. Just looking at this, right?
Correct.
So this guy is definitely the person who needs to be like, considered. And then we will continue going like right side also. And you may find maybe something is totally like uh, like everything is decreasing afterwards, right?
Yeah, for the only reason I took this example was because we figured out like 6 and 9.
Mm-hmm.
In the current example as the tripping point where we know like from 6 to 9 we have to, if we can sort, then the whole array is sorted, depending
Yeah,
upon, yeah. But in this case, like the higher number is 20.
yeah,
Like onto the very left we have 20, and onto the very right we have 15. Okay, so if we go from left to right we will figure out 22, and if
yeah.
we go from right to left we will figure out 9. Okay, so definitely 22 and 9 are not the correct answers.
Right. So you will also continue actually. So you will not stop there itself. You will continue popping out values. So you remember that when you will pop out in future. So let me write here 20, 22, 21, and we have suppose same thing like 648. What do you want to put here?
8, 10, 9, 15.
8, 10,
9,
9,
15.
15.
Yeah.
So, okay. So this is the first time we figured out, hey, there is some problem with 22. We will consider this guy. But I'm saying we'll consider, not like this is the like, guy. So we'll maintain 22, 21 was fine. Then when 8 will come, what will happen? We are maintaining this guy, increasing, right? So 8 will kick out even 20.
Makes sense.
So what will happen? Your consideration is already here when you will go through the entire process.
Okay, so we will move back.
Yeah, we'll move back. So we will not just find one and we are breaking. No, we are not going to do that. Got it?
Yeah, make more sense now.
So same thing, same idea, and it's good to like put more examples to like figure this thing out, because actually sometimes you will put example, you will figure out that actually you are not understanding things that well. I tried to optimize some things and I was getting error myself while I was going through some of these problems. But yeah, this is how it works. Go through it, you will figure out where to stop, how to optimize. So the concept is clear, guys, right? We'll find both the extreme, and once we find both the extreme, we have to just return the difference between this left extreme and write a stream, because that's what they are asking, like how many days after that you will have the same. Actually, no, it's a continuous subarray. So you have to sort these values.
I have a question. Last time we, with one iteration, we can figure out both answer for in both array, right? Why can't we do the same? Why can't we do the same in this problem?
Oh, that, what do you want to calculate the first? So in the previous, like, we, Gaurav just discussed something, right? That when you are, what you are interested in, like, that increasing stack, you are building increasing stack that will give you first a smaller value, right? First a smaller value, whether it adheres to the rule or it breaks the rule, you always get the smaller value. But you also have to get some higher value, like what is the first, like, bigger number towards left or right. You are interested in that too, right?
Right.
Or just do it from, like, decreasing way from the right, which means the same thing. So anyway, you have to go through that process. So it's a good thinking, but that's why in the beginning itself, I told you, I recommend after this session, go to the same problem with the current understanding and run some examples and try to apply it. And maybe I am not giving you the best solution. That's possible because I haven't devoted too much time to testing all those things. What I'm trying to give you is a framework where you can apply all these things and it will work. Maybe you can optimize it, but as I talked in the beginning, that is not like, currently we are not going to go into that. Is that fair?
Yes, I guess like we may optimize it, but then like it's like a very hard to visualize right away because you have to maintain like some additional information. So the simple solution like which we can combine to come up with the solution with the bigger solution should be straightforward to understand.
Yeah, I mean, that's what we decided in the beginning itself, that this is what we will do today. So if you have a better solution or we want to discuss, we can always discuss after the session, and then feel free to suggest ideas.
Yeah, I'm looking at it. I don't think it's gonna work because for first iteration we have to maintain the stack in increasing order, and in this case, the second iteration we have to maintain the stack in decreasing order. So it's not applicable to.
Yeah, that's what I thought, but yeah, I never tried to optimize it. So with that, any further questions? Now like at least one way to solve this, right? Increasing from the beginning and then decreasing from the end, and we figure out those two extremes. And if these two extremes, if we sort that, we get the answer. So with that, actually, let me share my code very quickly. It's the exact same logic which we just talked about, and I have added some comments, so that will help. Find first value from left, which is not correct, and monotonically increasing stack, we are building that. We found the leftmost value. Similarly, when going from right to left, we did the same thing and we figured out the right value. And after that, we just return the difference between that. So that's this problem. Take a look later, try to solve yourself, and then you will understand better. So we can go to the next problem next. And luckily next two problems we solved last week itself. So I am hoping that you guys are familiar with the question and solution, hopefully. But now with this knowledge, this should ideally become relatively easy to think like why we are building this, how it is helping me to solve this problem. So next greater element is the next problem. You are given two array like num1, num2, and here we are given that number 1 is subset of number 2. Okay, and what you have to find, like what is the next greater element for 4, but not in this array, not in number 1 array. You have to look into the number 2 array, like what is the bigger number after 4. So if you look at it, there is no number which is greater than number 1. So that's why we will say -1. No one is greater than 4. For 1, we will look at number 2. We'll find 1 here. And what is the number which is greater than 1? It's 3, the immediate guy. So that's the value 3 here. Same with 2. We'll first look into this, this array 2. What is greater than 2? And next means like towards right, there's nothing, so it's -1. So guys, question, forget about this. For example, like I don't like this mapping and all, like just don't think about it, just make it simpler. You are given an array, and if I am asking you to figure out what is the next number greater than 1 towards right, do you already know the solution or not? Based on today's discussion, I mean, that's what I'm saying. Like,
Yes.
we, in the first, like, basic itself, we have found the solution for this particular problem and many more, like 4 problems actually similar to this. So this should become mechanical, that, hey, I actually already know the answer for it. That it's just like, I don't have to think while solving this, that I know answer for 1, 3, 4, 2. I can just use a like decreasing stack in this particular case, because we are looking at a larger number. Whenever you look at larger, then you build a decreasing stack. So, okay, now the problem will reduce to, okay, if I have this information, then what the leftover, what is the problem? So then problem is just basically mapping. Like when I see 4, then I will look at, hey, where does 4 lies here? Okay. And what was the value for 4? It was -1. Okay. And let me fill that value here, -1. So it's a very small problem. Let me try to just, in 5 minutes, let me just try to make it clear. Maybe there are some guys who didn't go through the session. So I will just try to solve it. So your number was, number 1 is 412. So 412. This is num1. I am going to spend whole my time on number 2 because it is like superset. 1, 3, 4, 2. So guys, we know the solution for this. What is greater than 1 is 3. What is greater than 3 is 4. What is greater than 4 is nothing. For 2 also towards it, there is nothing. With the theory which we just discussed, we have the answer for this already calculated. And for number 1 here, if I have to solve, okay, so what I will do, for 4, I know the solution is here. For 1, I know the solution is here, right? And for 2, solution is here. So what will you do?
While going through the number 2, put them in a map. Because
Right.
while we are creating the array, because the ultimate goal is while we go through the number 1 array again,
Right.
we should be able to figure out what's against 4
Exactly.
or 1 or 2.
Yep.
Are we storing in the memory and using that instead of calculating? Is that so?
We are storing in memory thus this solution. That's the approach I'm going through. And as Gaurav said, what all you are left is just to map this thing. So when I am going through, because I have to answer for this guy, that what, like for value 4, the question is, what is the value in number 2 which is greater than 4 towards right? I have the solution for this guy already calculated. So all I have to do is map it. So instead of in array, what we are saying, okay, for 1 the value is 3, for 3 the value is 4, for 4 the value is -1, and for 2 the value is -1. Now when this guy looks for value, he will say, okay, what's the value for 4? Just a simple key lookup, and he can say, okay, so this value should be -1, whatever is the value. For 1, it will look into this map again. The answer is 3, so this will be 3. For 2, it will go through this, and the value will be -1. So the same process, but instead of array, we are putting this value in a map to facilitate this faster lookup. Any questions? No questions. Maybe, yeah, we solved this problem recently. So now you know like why we build this kind of stack in more detail. So we are done with this problem. Let's go to the next. So this one is next greater element 2. We also solved this problem last week. It's the same problem, but here you have the circular array. You are still trying to find next greater element. So for 1, the next greater element is 2. For 2, there is no element actually. So it will be -1. And for 1, it's not ending here. That's the thing. It will continue to roll. So it's a circular. So after 1, you will start looking to the leftmost guy. Then you will look into the next guy towards right. And again, we have a value which is greater than it. So it's 2. So that's the solution. Okay. So it's the same problem. Only thing, there is a trick here, which we talked during the previous session. So guys who have already went through this, they may know it. Can someone talk about it? So you had this value.
I can talk about it like if no one is. So
yeah, sure. Your answer should be 2, -1, and 2. So while Gaurav is talking about it, I will take 2 minutes break. I will grab water and then Gaurav, please continue.
Okay, sure. So now the array is circular. So there are like two different approaches. The question says we have to figure out the next greater element. So from the Rogers session, it's very clear that we have to create a monotonic decreasing stack to figure out the next greater element. Now, the only difference is if the array is circular, okay, how you can go beyond one, like 1 to 1, and then how you can go beyond 2. So we talked about two different approaches last time. The given array, we can iterate, we can create a copy of that array. Um, so we can have a array as 1 to 1 and then replicate that array again 1 to 1, which will be kind of consuming, if the size of the array is n, the array that we construct should be the size of 2n. The first half will contain 1 to 1, and then the second half we will like replicate the same array. So it will give you a linear array of size 2n, but the elements after the half are the same as elements in the first half. So we will kind of like roll to the starting index. The other way around is we can manipulate the indexes when we are traversing from 0 to 2n, 2n minus 1. If the index goes beyond the array length, then we can do a modulus of modulus with the length n. Those are the two, I believe,
Yeah,
patterns.
yeah, you're right. So what I'm trying to demonstrate, the concept, why that works a little bit, like mentally, hopefully it will work. So the only problem in this current approach is, other than the previous problem, is things are circular. So while I'm working for this guy, I will look at this, 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 right? So what I'm looking at is 1, 2, 1. When I'm working at index 2, what I will be looking at is this, this, and this, right? So when I'm working at here, my numbers are 2, 1, 1, right? Now, when I am working for this guy at this place, I will look at this, this, and this. So when I'm working here, I will be looking at 1, 1, 2. If you merge these three things, what you are going to get? 1, 2, 1, 1, 2, right? This is just like a clock. Like, so when we are saying that we will add two arrays back to back, this is what we are anyway getting when you will try to add these things. Just one extra value, 1, 2, 1, 1, 2, 1, right? Is that clear, guys?
Yes.
Okay. So now the problem is same. We have already solved this problem, that if you are given this array and you can calculate values, like the answer for this, then that's the problem. The only thing is, what is same? The thing is, this 0 index, 1 index, 2, 3, 4, 5. So here we can say that 0 and 3 actually mean the same thing. 1 and 4 mean the same. 2 and 5 mean the same. Because on that clock, you will see actually they are the same values. They are the exact same guys. So when we are calculating answer, we have to still, my result is still this 3 value. Like, they only have these index 0, 1, 2. So when I get an answer for 3, I have to make sure that I'm updating value 0. For 4, if I get some answer, I will still update 1. For 5, I will still update 2. And that you can figure out using the mod operation, right? Because why 0 and 3 will be similar? 3, remainder 3.
Mod 3.
Yeah. Same 4, 3, 5, 3. This is 0, this is 1, this is 2. So with this simple trick, we have solved already this problem. So we can look at the code very quickly and we can move on, because there are harder problems later and we have solved this. And I think we have already gone through this idea. Simple problem, same thing. We are going through this monotonic decreasing stack. Now we are going through like array of 2 into n length. And the only difference is we are making sure that we put the value whenever it is reaching more than 3 or more than actually 2, the value which are actually in the array. So 3 will get transformed to 0, 4 to 1, and so on. Similarly, while popping out, we are just updating that result value. Go through this example with on your own, and I think it should be pretty easy to solve this problem. All right. So we solved these 4 problems. These were kind of very direct in implementation of the theory we just read. Now we can go to a couple more problems. Should we continue going? Or if you guys are tired, I can stop, but we can go through it. I have already solved it. So,
Hey, Roger, I would suggest taking maybe a next session.
okay.
Maybe if you want to do over the next week.
Yeah, sure.
Weekend, because
Yeah.
I'm seeing people dropping off.
Okay.
So
yeah, I'm okay. I'm okay. Whatever works.
Yeah,
So,
I think you already have solution. Maybe you can quickly walk through also.
Yeah, I think it quickly go over that, then we can
Sure.
look up the solution.
Okay.
Okay. Yeah, the thing is, it will be these are harder problems, so it may need more time, but we'll see how we can go through it. So this problem is online stock span. So you are given a stock spanner class, and the problem is, so yeah, meaning of a span is the span of the stock's price today is defined as the maximum number of consecutive days starting from today and going backwards, for which the price of the stock was less than or equal to today's price. It's so for example, for 100, there is no backward, so just 1. For 80, was there any value towards it left which was smaller than 80? Actually, there was none, so it's just 1. Answer for 80 was 1. For 60 also, if you look towards left, there was no day when the value was less than 60, so still 1. For 70, there is one value towards left, which is 60, which is also smaller than 70. But then next value is 80. So we can say actually the stock span is 2 day. For 60, again, there is nothing towards left, which is smaller than 60. And it has to be consecutive. So you can't count this 60. You always have to look towards left, decreasing sequence. For 75, there is here 60 is okay, 70 is okay, 60 is okay, 80 is not okay. So up to this one. So this will become 4, because you include 75 also, and these three guys, so that's why it's 4. For 85, the same thing, you can go from here all the way up to 80, so it's 6 value. That's the thing, that's the question. So you are going towards left and you are finding when the value is less towards left. So at least the pattern is similar, right?
Yes.
Okay. So pattern is similar. And then the problem is, I think, if you look at it, I haven't spent too much time. I think they have made this bound such that if you do like solve it in a brute force way, it probably will not be accepted. So that's why we need to optimize a little bit. That's the main challenge here. Okay, so let's try to solve this then. I will try to stop sharing. I will try to go to the screen. And also we'll see what is important. That is also important. So 100, 80, 60, then we have 70, then we have 60, then we have 75, and then we have 85. Okay, so for 160, okay, if you look at something, okay, for 70, for example, for 70, 60 is good, like it will increase its value, but 80 will not. That's right. For 75, again, these guys will add to its value, but 80 will not. So think about it. If you had this kind of a stack where I have some value for 80 and no value for this, and then a value for 75, like let's call it x, let's call it x plus 3, actually x plus 4. But if I don't have it on a stack, only just for like 75's point of view, then 75 can say, hey, actually my value is x plus 4 and this value is x. I can actually derive this, that okay, there are 4 values which are smaller than me. So on that idea, actually we can optimize this thing. And I will show you how.
So here the goal is to again create a monotonic decreasing stack.
Yes, you're right. So you got it.
Yeah, because looking at the problem,
Yeah.
we're trying to figure out what's greater than me onto the left.
Yes, exactly.
Greater or equal, maybe, because that is the given problem.
Right. So what we are saying, when 100 came, let me store that 101. And one means like that the value which is equal to me or less than equal to me towards left. 100 is starting with this, then 80 came, then 80 will say, okay, 80 and 1. That's fine. And this is my stack. My stack is in this direction, like I'm filling this value. 60 came. So still we are maintaining this decreasing stack. No problem. 61. So far so good. Now the thing is when 70 came. So 70, what it will do, it will say, okay, look at the stack, keep moving stuff, removing stuff which are smaller than me, but stop wherever, there is a guy bigger than me. So when 70 removes 60, it increases one count already, because we count one value which is smaller than this guy. So we can have here 70 and 2. Does that make sense? I would have put 71, but since we just popped out 60, now 70 represents that for all useful purpose, you can consider that there was one value. I am already giving you that information right here. So 70 represents that there is two value including itself that was less than 70 towards left. Then 60 comes, then we can have 61 because 60 is still smaller than 70. Okay. Then 75 comes. Now what will happen? This guy will go out. This guy will go out, right? So now your stack will start looking like these all went away. So now you have 75 and 4. What that represents, that towards my left there are 4 values which are equal or smaller than me.
75.
Okay. So 1 plus 3 itself is 1 plus, as we pop it out, then we add with the second.
Yeah, 2 plus 1, 1, and 75 also has its own value, like on day basically.
Okay.
So that's why we are adding 1 everywhere, like 100 had 1, 80 had 1, so something like that. So now 85 comes. What 85 can do, 85 will kick out 75, it will kick out 82. And 85 had its own value also. So what will be the next step is 85, it had its one value from itself, 4 from here and 1 from here.
6.
So 6. So you are at the end of this, your stack will look just like this: 101, 85, 6, and that's it. So while you are continue to make this decreasing stack, you are maintaining this extra information also. So you don't have to go one by one and remove things, and then you are saving a lot of time there. The same concept, actually Gaurav already recognized it very fast, but you start to recognize this pattern, like what I'm interested in, and then how can I apply stack to do that. After that, you can look at the code. It's like 4 line of code basically, straight implementation. Okay. So what should we do next? Should we still do the next 3 problems, or you want to do it later?
Can we do the, I mean, if no, can we do the second to last problem?
Yeah, who is this guy? Amazing line. He always finds the hardest problem, but good. I'm okay. Actually, we can do all these problems, guys, but the thing is, I try to make it faster, but these things go very, it takes time. So, okay, 132 pattern is very similar. I will just show you the code. Go ahead and try to apply this same concept. We are not going to do this today. For example, Rajesh rectangle in a histogram. It's a very, very nice problem, but the same thing, you will be maintaining increasing a stack, and all we are going to figure out based on that is height and width. And width is the thing which basically will give you the for a given height, what could be the width of the histogram. So by like, having these indices, you can figure that out. I would suggest, or maybe we can do like, another session when it again this problem comes up, I can go into the detail, is like put sometimes like, just increasing value and see what happens. Put sometime decreasing value and mix those. Then you will be able to derive like, couple of like, these kind of checks, like when I is height dot length, what does that mean? When the stack is totally empty, what does that mean? But other than that, look at this code. Like you have exact same 3 line of code. So the core concept is still same. Nothing changes, just application. And this guy is a like, hard problem if you look at it.
Yes. Now, like since you explained increasing or decreasing stack,
Yep.
this problem looks like pretty straightforward.
Yeah, that was my whole like, reason to do this session, that you guys start to think it like mechanical. You don't have to spend your mental energy on figuring out like how would we do, how should just come, okay, I know something I have to do with this. Then you just start putting use cases, and then you can derive these conditions in yeah, 10 for 15 minutes you should be. So great. So with that, I think we will just do today's last problem. Actually, in my opinion, this was closer to hard problem, by the way. It's a medium. So sum of sub-array minimums. Sum of sub-array minimum. So this problem is, let me try to share my screen. Okay, so sum of sub-array. So 3124. 3124, was that the example? Have to check that. Yeah, 3124 is the example. So 3124, and the story is like sum of subarray. So the problem is how many subarray you can make. You can have just 3 by itself, 1, 2, 4, all by itself. So you know the value here, 3, 1, 2, 4. Then you can have 2 guys at a time. So 3, 1, and then 1, 2, and then 2, 4. So what is the value here? Minimum is 1, here minimum is 1, here minimum is 2. Then 3 guys at a time, so 3, 1, 2, and then 1, 2, 4. So 3, 1, 2, what is the minimum? It's 1, and then here again 1, and then 3, 1, 2, 4. 3, 1, 2, 4. What is the minimum? It's just 1. Okay, so what's the sum? 3 plus 1 plus 2, so 10 here, 4 here, 2 here, and 1 here. So overall you have 17. So you have to find that sum of subarray minimum. And how do we solve this? That's the thing. So I will give you one, I will ask you a question actually. So the question is clear, guys?
Yes.
Okay. If the question is clear, then one observation which is useful is, okay, let me erase. One important concept here which is required. Suppose you have an like subarray here. You have value here. Let's call this value x. You have more values here. You have 2 values here. Let's call it A and let's call it B. A is the first guy towards left, which is smaller than X. B is the first guy towards right, which is also smaller than X. That means that in this whole subarray, X is the minimum guy, right? Because that was the first guy who is smaller. Means all these guys are bigger. So X is the minimum in this entire area. Is that clear? I mean, it's just a statement, so it should be clear.
If it's smaller than X, if A is smaller than X, and B is also smaller than X.
No. So A is the first guy who is smaller than X towards left. A is smaller than X. B is also smaller than X. This is towards left and this is towards right. Okay. So can we say in this particular area, X is the minimum?
Yes. Oh, the minimum.
Yeah.
I'm sorry. Okay. Yeah.
Yes.
Clear. Okay. So if that is true, then we can also say that no matter what you build using all these guys, doesn't matter which kind of subarray you create, I always know the minimum value will be X. And if you remember, the problem was that for each subarray we are going to create, we will add the minimum value.
Yes.
Right? So if your subarray was 312, you only care that what is the minimum in this, and that was 1. So you were just adding 1. If it was just 1, 2, still 1 is the minimum. If you just have 1, still the minimum is 1. Okay. So that's the crux of this. So if we find a way that if X is the minimum for any particular subarray, then how many such subarray I can create? If I can say, hey, actually there are 6 such subarray, then I can say, hey, for then, why don't you increase 6 into X? Just add this 6 into X to my overall sum, because I know that minimum value is X. And if there are such 6 subarrays, then I can just add this to my solution.
Correct.
Make sense?
What do you mean six sub array from A to B?
Yeah, I just assumed, but
Okay.
let's look at it. Like if there were 6 such subarray you can create. So like, for example, let me take one example which I had written somewhere just to demonstrate this thing. I had one particular example. Okay. 278341. So 278341. Okay. Here is your X. Here is your A. Here is your B. The same example. Does that make sense so far?
Yes.
Okay. So now see how many such subarray we can create for this guy. One thing is I can say, okay, 783. I can create 7834. I can create 83. I can create 834. Okay, I can just create 3. I can create 34. Can you create anything other than these?
No,
Why not 7, 8?
because it not include 3 and not include X.
So we Yeah, that's my idea, that including X. And so just look at from 3's point of view, like where 3 is the minimum. You will not include just 7, 8 by itself. Is that clear?
Okay.
Yeah.
Okay.
Then we need to check. Then we need to check for every other element in the same way, right?
Can somebody hear what was the question?
No, it's hard to hear.
Yeah. So my question is, do we need to check for every other element in the same way, just like how we are checking for three?
Yeah, exactly. So 3 was just an example, but we will do this, the check for each of these guys, for 8 also, for 7 also, everybody, like that, where they could be the actual candidate. That's right.
All right.
Okay. So we are breaking the question. We are just choosing one to, like, to give some ideas. So now what I can do, if I know the distance between these two guys, and I know the distance between these two guys, what are these two guys? The first is smaller to left, first is smaller to right. If I say that this distance is 3, for example, and if I say this distance is 2, then the claim is we will have 3 into 2 such subsets. Because when you choose 3, then there are 3 ways in which you can choose the left side of it. 2 values plus you don't select, that is also one choice. I don't choose anything from left side. I choose one value, I choose 2 values. So 3 ways from left side. In this particular case, 2 ways from right side. I can choose 4 or I cannot choose 4. So as we saw in the example, there will be 3 into 2 ways. So I can generalize that if I know the distance between this thing, which is like, let's call it M, and this distance is N, then I can build M into N subarray where 3 is the minimum. So what will be the sum? M into N into 3, just for value 3.
Makes sense.
That's great. Very clear. If it is clear, and as the other guy was someone asking, we will do the same thing for all of these guys. So for all of these guys, do we know how to find the leftmost guy which is smaller than him? Do we also know how to find the rightmost guy who is smaller than him? I think we have already solved a lot of problems like this today. So we have solution for that too.
Increasing array. Like using the monotonic increasing array.
Yeah. Exactly. You got it. Exactly. You are looking at the small, so it should directly come to your mind that increasing stack I can use.
So we have to create like 2 arrays the way like you showed in the first example.
Exactly. So with that, you should be able to calculate, and let me share the code very fast. So you already know the idea of this. This is the center of this. You created monotonic increasing stack, and you keep updating the left and right value based on what we talked earlier, and you go through each of these values and you just do exactly what we did. Number into left into right, and you have to mod some value because that's given in the problem. So you do that, and that's it. Is that, at least it makes some sense, right? Then what? Yeah, After this session, I would strongly recommend go through all the solutions and go through the basics. There is a REPL for it here. I have already shared it. Go through this first. Try to understand all of it. Once you have done that, go through these problems. Try to see why I am creating this stack, what I will get from this, and then I'm pretty sure you will be very confident, at least more confident than what you were earlier. And if you already know, then yeah, then you are not learning something new. But during this process, when I was thinking about it, I myself learned a lot. So I just want to share, okay, let me try to give you a lot of other type of problems, even harder problems. I solved this one recently. I had solved earlier also. This one was the best problem I liked, actually. I wanted to demonstrate that anyway. So
Question on line number 30. Why you do 2 mod?
oh, because this value can also increase, could be greater than 10 to the power 9.
Oh, okay, got it.
Yeah, for more clarity, I could put it in a bracket like this. Maybe that would have been clearer. Maybe something like this. But yeah, that's the main agenda for today, guys. I will.
Awesome, Roger, because it clarifies a lot of concepts. And now I'm looking at all these problems in a entirely different way.
Exactly, that should be the idea. Solving 1,000 problems that won't help.
Can you mute the other guys?
Yeah, let me try. So what I was saying that, yeah, exactly. Solve less problems, but try to find what we are learning from each problem. Try to generalize that information. How can we generalize so that we can apply it in other problems also. It takes more time in the beginning, but believe me, if you understand this basic, for example, now it will become much easier for you. It, and you will start enjoying also, right? During the session, how many times you already figured out what I'm going to talk about. I mean, so that's what we want to get at. So do less problems, but yeah, try to generalize. Anybody has anything to talk about? We can stop the session and we can talk a little bit.
Yeah, just stop the recording, I guess.
Okay.